Hello, everybody. In today's lesson, we're on page 455, and we're talking about the topic join and separate angles. And so our essential question is, how can you determine the measure of an angle separated into two parts? And so you'll need construction paper, scissors, and a protractor. And so the first thing you need to do is draw an angle that measures exactly 70 degrees, and we're going to label it triangle, measure angle ABC. Oh, not measure. Label it angle ABC. Okay, so I've drawn mine, so you might want to pause and draw your 70-degree angle. And so here's my 70-degree angle labeled ABC. Okay, now we're going to use scissors and we're going to cut out triangle AB. I keep saying triangle. We're going to cut out angle ABC. Okay. All right. So we have our large angle, and I kind of just drew a line so I could have something to cut along. We're going to cut through the vertex to separate the two angles. Okay, what did we form? Well, if this is an endpoint, this part of the construction paper is another ray. So we've actually made two angles now. Okay, so when you cut an angle in half or into parts, you form that many angles. If I cut it into three parts, I would have three angles, so on. Okay. Okay, now use your protractor to measure your new angles. Okay, so make sure you find the end point of your ray. Okay, not the end point of the green paper if you still have a part of that left. Line it up with zero. Line the ray up with zero. Okay, and mine is at 25 degrees. Okay, 25 degrees. So I'm going to write 25 degrees for one of them. Okay, and then measure your second one. Put your protractor at center point on the vertex. Line up the ray with zero. And I'm at 45 degrees. Okay, so find the sum of the angles you formed. All right, so we have a 25 degree plus a 45 degree equals, well, 5 and 5 is 10. Regroup the 110. 4 and 2 is 6, plus 1 more is 7. We get 70 degrees. Well, that kind of makes sense, right? My original angle was 70 degrees. I cut it into two parts, one part being 25 degrees and the other part 45 degrees. When I add them together, it makes sense that it would come out to 70 degrees. So F, join the two angles. Compare measure angle ABC to the sum of the measure of its parts. Explain how they compare. So these were the two. When we put it up together, it forms the original angle. Okay, it makes a 70-degree angle. This was 45 degrees, and now was 25 degrees. And 25 plus 45 is 70 degrees. So we can say the measure of angle ABC equals the sum of its parts. sum of its parts. Okay, let's see what we got on page 456. When you cut out angle ABC into two different, what if you cut angle ABC into two different angles? What can you conclude about the sum of the measures of these two angles? They're still going to be 70 degrees. Okay. The sum of the angles measures, sum of the two angles will still be 70 degrees. The size of the angle, the size of the original angle that measured 70 degrees did not change, just the measure of the two cut angles. All right, Seth cut angle ABC into three parts. Draw a model that shows two different ways he could have separated his angle. All right. So again, if we have our 70-degree angle, go ahead and draw a 70-degree angle. Okay, line it up with 0. Okay, and find the 70 mark. Make sure your edge of your protractor is lined up the 2 points. And draw that in. Okay, so we're going to call that B, this A, and that's C. Now, what are 3 ways we can make 70 degrees? Well, what if I made 2 of them 20 degrees each? That would be 20 plus 20 is 40, and the third one would have to be 30 degrees. So let's make one of our angles, one of the angles, 30 degrees. So we're lined up with 0. 30 is right there. Line it up with the vertex. Okay, and actually that's off. Should have went like that. And then we have, so this angle is 30. And then we want to split that into 20. 20 degrees is right there. Line it up with the vertex. Okay, and you see we have 3 angles. So 20, 20, 30. And then let's draw another one. I don't know, 40, 20, 30, something like that maybe. So draw a ray. So start with your 70-degree angle. Okay. Line it up with 0, the ray with 0. Use the same scale, find 70. Line it up. Draw in your angle. A, B, C. Okay, so let's go 40. I'm going to go 40 degrees. You can do anything that adds up to 70. So I'm lined up with 0. 40 is right there. I'll line it up with the vertex of angle ABC. Okay, so this angle is 40 degrees. I need to now split this into a sum of 30. Well, let's make one of them 20 degrees again. So measure the middle angle and find 20 degrees. Degrees is right there. Connected with the vertex. And there's our 3 angles. So this is 60. How much is this third one without measuring it? It's 10 degrees. Okay. All right. So 2 different ways. Bottom line, the sum of the 3 angles has to come out to 70. Write a sentence that compares the measure of an angle to the sum of its parts. The measure of an angle is equal to the sum of the measures of its parts. And we've already mentioned that, right? We've actually even written that already. So write a sentence that compares the measure of an angle to the sum of its parts. If I add up the measure of the sum of its parts, this one has 3 parts, it'll give me the larger angle. All right, now for this next section, we need a protractor. And we're going to be using a protractor to find the measure of each angle in this circle. Okay, well, we know a circle has to add up to 360, right? So let's start with angle ACB. ACB. Line it up with 0. I want to go ahead and extend it out a bit so I can read it better. Okay. Okay, it looks like 85 degrees. So I'm going to say ACB is 85 degrees. I was measuring. Oh, no. ACD. Okay, I was on this side, right? So 85. Now I'll do this angle. All right. So this ray is going to 0. Okay, so now I need to use this side for this angle. So make sure you're on 0. Okay, 10, 20, 30, 40, 50, 60, 70, 80, 95. 95 degrees. All right, and this one's the easiest one. It's straight, 180. All right, so 85 plus 95 plus 180. Well, what is that? 85 plus 95 is 180. That makes sense. Half of a circle is 180. So 180 plus 180 is 360 degrees. Okay. All right, 457. add to find the measure of the angle, and write an equation to record your work. Okay, so they gave us the measure of PQT, and they're saying it's 43 degrees plus 37 degrees. All I have to do is add them up. 7 and 3 is 10. Regroup to 110, and we get 80 degrees. Okay, and that makes sense. This is slightly smaller than a right angle. So measure of angle PQT, 80 degrees. All right, angle 2, number 2. We have 90 degrees plus 10 degrees. Well, that's 100 degrees. 90 and 10 more is 100. And that makes sense. You see how it's slightly, angle JKL is slightly bigger than the 90-degree angle. Okay. How about 3? Okay, I see 3 different angles. We just have to add up the angles to find the measure of SHR. 57 plus 27 plus 78. All right, 8 and 7 is 15 plus 5 more is 20. 5 and 2 is 7. 7 and 7 is 14 plus 2 more is 16. So 160 degrees. All right. For numbers 4 and 5, use a protractor to find the measure of each angle. Label each angle with its measure. Write the sum of the angle measures as an equation. Okay, same thing we've been doing. All right, so I'm going to put the center point of my protractor on L. I'm going to line up this ray, LJ, at 0. I'm going to measure how wide it's opened going to the right. Okay. So there's the center point. I'm lining up my ray with 0, and I'm going to find where it crosses. It looks like 60 degrees. Okay. Oh, it's good that I'm doing this. I want to show you something. Okay. I told you that the 0 was going this way, right? Well, I immediately just went to the inside. That's the wrong scale. If I'm using this ray as 0, I have to use the outside starting with 0. Okay? So it's easy to make a mistake. All right, so we're still in the same spot, but not 60, but 120. Okay, so this angle is 120. Okay, now I'm going to put the center point back on L. I'm going to call LM 0, and then I have to make sure I use the same scale to see how wide this is open. All right, so put it on 0, the center point. Line it up with 0. Okay, 0 is right here. Trace it around till it crosses. And it looks like it crosses at 140. All right. Without measuring the next one, right now I have a sum of 260. I'm going to assume that this one is 100 degrees because the circle has to add up to 360. And right now we have 260. Let's see. Doesn't really matter where you put the 0. I'm going to have LM be the 0, and I'm going to measure LJ. All right, so that's 0. I'm going to trace it around and it is at 100 degrees. Okay, so the measure as an equation. So 100 degrees plus 120 degrees plus 140 degrees equals 360 degrees. All right. Now let's do the next one. All right. I'm going to put the center point at V. I'm going to make Z the 0, and I'm going to measure to see how much is opened in between Z and Y. There's the center point. I've lined it up with 0. 0 is right here. I go around till it matches, and it looks like exactly 90 degrees. All right. Now, this YW makes a straight line, right? This side has to add up to 180. This side has to add up to 180. What do you think this one is? Well, if I've got 90 here, and this is actually perpendicular, this should also be 90. So let's do that. Let's measure this one. So we're going to use V as the center point. We're going to make W the 0. And we're going to measure to see how much distance there is between W and Z. Okay, so I line up with 0. I find 0 on the protractor, and I go around till it matches. And it's, again, right at 90. All right. Now, looking at the remaining two, again, this side's going to have to add up to 180. This angle here looks greater than 90, and this looks less than 90. All right, so let's measure. Again, we're going to put V, the center point at V. We'll make W the 0, and we're going to measure how much it turns to get up to X. So there's 0. It's lined up at 0. 0 is the inside scale to get to X. And it looks like 135. Okay, that makes sense. I'm going to assume that this is 45, because 45 and 35 is 80. I'm going to make V the center point. I'm going to make X the 0. And I'm going to measure along the same scale to find out how much it turns to get to Y. Okay, so put the 0. Make sure you line up with 0. And the center point is there. Okay. And where does it cross the protractor? Right at 45 degrees. Okay, so we have 90 plus 90 plus 45 plus 135, and that equals 360 degrees. Okay, awesome. Okay, what is the measure of QRT? QRT. Okay, the clue here, I'm going to outline it, is that angle is a straight line. So the sum of these three has to be 180. So let's add them up. We have 75 plus 85. That gives me 160. Well, 180 take away 160 equals 20 degrees. QRT equals 20 degrees. Again, what did I do? I added the 2 that I had. That gave me 160. I know that because it's a straight angle, it has to add up to 180. So 180 take away 160 that we already have, leaves me with 20 degrees. Look back at exercise 1. Suppose you joined an angle measuring 10 degrees. to PQT. Draw the new angle showing all three parts. What type of angle is formed? Okay. I'm going to say C number 1, and I'm going to draw in just the 10 degrees. All right, so let's use this as our 0. QP, I'm going to use QP as my 0, and I'm going to find 10 degrees. Oh, 10 degrees is off my paper. Okay, 10 degrees is right at the E of name. Okay, so then join it together. All right, what did we form? We formed a 90-degree angle. Showing all three parts, right angle. Okay. A little off if I ask myself. All right, page 458. Stephanie K and Shane each ate an equal size of pizza. The measure of the angle of each piece was 45 degrees. When the pieces were together, what is the measure of the angle they formed? Okay, what are we asked to find? When the pieces were together, what is the measure of the angles? What is measure of the angle, including the three pieces, including the three angles? What information do we need? That they were each 45-degree angles. Each piece was 45 degrees. Tell how you can use addition to solve the problem. Well, it's just going to be 45 plus 45 plus 45, right? So let's go 45 plus 45 plus 45. Just add the measure of the individual angles to get the sum of the larger angle. Okay, 45 plus 45 is 90. 90 plus 45 is 135. So you made an obtuse angle or 135-degree angle. Okay. Number 9. What is the measure of XZW? Okay, I don't need to measure anything. It's already told me the measures. I want XZW. I want the larger angle. It has 2 parts to it. So 42 plus 71. So just add those together. It's 113 degrees. All right, and number 10. What is the measure of angle PRS? PRS. What is the measure of that? Okay, use equations to explain and check your answer. Well, isn't SRT a straight line? a straight angle? Okay, so we know that it has to be add up to 180. So something plus 90 plus 78. So 180 equals something plus 8 and nothing is 8. 9 and 7 is 68. So 168. Well, 168 plus something is the same as saying 180 take away 68. It leaves me 12 degrees. Measure of angle PRS equals 12 degrees. Okay, so to summarize in just kind of one sentence, to find the measure of a larger angle, you can add the measure of its separate angles. If an angle is broken into two parts, you would add the two smaller angles to get the large angle. So that's it for our discussion on that. Our next lesson, we'll be talking about problem solving and finding unknown angle measures. We actually did a little of that today. Okay, so until then, may the numbers always be in your favor.